Today we're going to go over the rules of exponents and how they relate to rules of logarithms. I already did something similar to this just for logarithms, but I thought it might be helpful to have a more fresh perspective on the rules of exponents to maybe have like a more fundamental understanding in the first place. So we have a to the x times a to the y equals a to the x plus y. It's interesting how multiplication here becomes addition there, but let's see it in action on the right side of the board. Let's say 2 to the third times 2 squared equals 2 times 2 times 2 times 2 times 2 equals 2 to the fifth. So, for the second rule, we have a to the x raised to the y equals a to the x times y. Now, just like multiplication here becomes addition there, exponentiation here becomes multiplication there. So, to work an example similar on the other side of the board, let's try, we're again using small numbers because it makes my life easier. 3 to the third squared equals 3 times 3 times 3 multiplied by itself. Equals 3 to the sixth, and that's 2 times 3. Now we have a over b dx equals a to the x divided by b to the x. And I guess, again, to work a small example, 2 over 3 cubed equals 2 over 3 times 2 over 3 times 2 over 3. And from what you remember about fractions, this is the same as just having one denominator and putting the exponent or the multiplication here and here is 2 times 2 times 2 over 3 times 3 times 3. Now that we're on the bottom side of the board, we have a to the x divided by a to the y. And this one's just a mirror of this first one. That equals a to the power x minus y. So where we can go from here is, let's say, 2 to the fourth divided by 2 squared equals 2 times 2 times 2 times 2 divided by 2 times 2. We know we can cancel this with that and this with that. So we have 2 of them left, giving us 2 squared. Finally, a to the 0 equals 1. Now to show this one is true, we're going to have to bring a couple other rules into play. Namely, the a to the x divided by a to the y rule. So let's say a to the 1 minus 1 equals a divided by a equals 1. And this works for any a. And for some reason, this also works in the case of 0 to the 0 is 1, even though 0 divided by 0 doesn't really give you a clean answer. A to the negative x equals 1 divided by a to the x. So if we can take the liberty here of substituting a to the 0 for 1, let's say a to the 0 divided by a to the x, which we know is the same as 1 divided by a to the x, is equal to a to the 0 minus x equals a to the negative x. And finally, the last exponent rule that we're going to cover here is a to the 1 divided by x equals the x, hard to say that, root of a. So let's go ahead and use the second rule to show that. So we know that a to the x over x equals a to the 1 equals a. But we can also use that multiplication rule to say a to the 1 over x raised to the x power is a to the x over x equals a. And we already know that the number that you can raise to power x in order to get a is the xth root of a. This should cover, in brief, the powers and rules of exponents.